All right, welcome. Today, we're going to put on our detective hats and dive headfirst into a digital mystery. We're going to investigate a web attack, piecing it all together using nothing but the digital breadcrumbs left behind in the code. So let's get this investigation started.
So this is the big question, right? For any cybercrime investigator, this is where it all begins. When a website gets compromised, the crime scene isn't physical. It's like a ghost in the machine. So how in the world do you find fingerprints when they're made of pure data?
Okay, so our first step is to secure and really get a handle on the crime scene. We're not looking for footprints or stray fibers here. We're hunting for weird little anomalies in server logs, in configuration files, and in the application data itself.
And this whole process? Well, it's got an official name: Web Application Forensics. It's really the science of rebuilding an attack by meticulously going through the server's digital records. And you know what our #1 source of evidence is? The log files. They're like this perfect, impartial witness that records every single request made to the server, no matter what.
But, this is no walk in the park. Modern web tech throws up a ton of roadblocks. Encryption can basically hide the content of the attack. Anonymizers like VPNs, they can completely mask where the attacker is coming from. And if the servers aren't perfectly time-synced, creating a clear timeline is an absolute nightmare. All these things are designed to make the attacker a ghost, and it's our job to find him anyway.
So how do we get around all these obstacles? Well, we turn to our key witnesses, the server logs. Every visit, every click, every single error, it's all recorded. These logs are pretty much the digital version of an eyewitness who has a photographic memory for every single detail.
Now, depending on the server's operating system, our witness speaks a slightly different dialect. If we're on a Windows server, we're looking at IIS logs, which use something called the W3C format. Over on Linux or Unix systems, we're dealing with Apache logs, which are usually split into access and error files.
This right here is where we start translating what the log is telling us. Think of it like this. The CIP field, that's your suspect's address. The CSURI query, that's where we often find the weapon, the malicious code itself, and the SC status code, things like a 404 or a 500 error, that tells us how the system reacted to the attack.
I know. At first glance, a log entry just looks like a jumbled mess of text. But once you know the structure, it reads like a sentence. We can see the entire journey of a single request. It starts from the client's IP address, moves to the specific question they asked the server, then we see how the server responded, and finally, what browser or tool they used to do it.
You know the saying, an investigator is only as good as their tools. And when you're staring down millions of log entries, you need way more than just your own two eyes. You need a digital magnifying glass. So let's look at the tools of the trade. On a Windows system, the MVP, your most valuable player, is a tool called Log Parser. It's a freebie from Microsoft that lets you search through these massive log files using a query language that feels a lot like SQL. It's kind of like being able to have a conversation with your log files, asking them very specific questions about what happened.
And check it out in action. With just this one line, this command tells Log Parser, hey, search all the log files and show me every single request that has the word select in the URL query. And boom, with a single command, we can instantly filter a mountain of data down to just a handful of potential SQL injection attacks. That's the power of having the right tool.
Now let's hop over to the Linux world. The very first tool you're probably going to reach for is grep. Think of it as the universal search command. It's incredibly fast and simple, perfect for finding specific keywords or patterns in any text file, including, of course, our Apache logs.
For example, this simple command tells grep to hunt for the phrase union select, which is a classic calling card of an SQL injection attempt. Just like that, the entire log file gives up every single suspicious request. It's beautiful in its simplicity, but man, is it effective.
But what if you don't just want to find lines? What if you want to analyze them? For that, we use awk. So while grep is great for finding the needle in the haystack, awk is the tool that lets you pull out specific pieces of information from each line, like just the IP address or just the status code, so you can start to see the bigger patterns.
And just look at the power of this. This chain of commands uses awk to grab the IP address and the status code from every line. Then it pipes that output over to sort to group them all together. And finally, unique counts them up. The result? A perfect summary showing which IPs were probing the site and getting a bunch of 404 not found errors. That's how you spot an attacker doing their homework before the real attack.
All right, we've got our crime scene, we've interviewed our witnesses, and we've got our tools ready to go. Now, it's time to find that smoking gun. Let's look at the specific digital footprints left by some of the most common web attacks out there.
First up, the absolute classic, SQL injection. So SQL is the language that applications use to talk to databases. This attack is basically like whispering a malicious command to the database behind the website's back, usually to try and dump out all kinds of sensitive information, like user passwords or credit card numbers.
And the evidence? Oh, it's hiding in plain sight, right there in the log. You'll see SQL keywords like select or strange-looking logic like or 1 equals 1 sitting right there in the URL. A very common companion to this is the status code 500, which is the server basically screaming, "Whoa, something just broke," often a dead giveaway that the injection attempt worked, but not cleanly.
Okay, next on our list is the malicious file upload. With this one, the attacker's goal isn't just to steal data, it's to take total control. They do this by uploading something called a web shell. It's just a small script that acts like a secret backdoor, giving them a command prompt on the server that they can use from their own browser.
And if you look at the logs, it tells this perfect little 3-act story. Act 1, you'll see a post request where the attacker sends the file. Act 2, a moment later, you'll see a GET request to that exact same file name. That second request, that's Act 3, the attacker checking to make sure their shell works and their backdoor is open. It's a textbook pattern. Another really common trick in the book is called file inclusion. This one exploits a weakness that lets an attacker basically trick the application into showing the contents of sensitive system files. Things it should never ever show, like the password file on a Linux server.
And the footprint for this one, it is totally unmistakable. You'll see these weird .. sequences in the URL. That's called directory traversal. And it's the attacker literally trying to walk up and out of the public web folder to get to core system files that should be completely off limits, like the infamous /etc/password file.
So, okay, we've walked through the crime scene, we've examined the evidence, and we've seen the tools to crack the case. But why does all of this work really matter? Because it's about so much more than just finding out who did it. Because at the end of the day, the goal of web forensics isn't just to catch the bad guy, it's to understand exactly how they broke in so we can fix that vulnerability and make sure it never, ever happens again. It's all about learning from the past so we can build a more secure future. Because every single action we take online leaves a trace. The real question is, who's looking for them?